So for example number 7, you're given dy dx is equal to x plus 1. Now you'd have to take differential equations, which is like calculus 4 in college, to solve that, to find y. Now I will tell you what it is. Y, in other words, the antiderivative of this thing is y is equal to some constant c, e to the x minus 1. Okay? And, oh, I forgot to tell you, they said that this passes through the point 2 comma 0. Okay? So problem number 7 says, use the calculator to construct a slope field of the differential equation dy dx x plus y, or equals x plus y, and then sketch the particular solution that passes through 2 comma 0. Well, the way that we do that with the calculator is you have to have that program. Now I've downloaded the program and installed it in my computer, and it's called Slope Field. I think it's option number 4. Let me make sure. Alright, so what I would do then is once I run the program, and this is a short program, you can program it into your computer or your calculator if you want to. But I'm going to enter in my function, and as you can see, it's x plus y. But look, I'm going to enter it a second time so you guys can see how to do that. I'm simply going to choose the letter x plus, and then above each button there's a blue letter. So I'm going to hit alpha, and then I'm going to find the y, which is 1, I think. Okay, and then I hit enter. Now that's done. Now what I'm probably going to do is I'm going to clear my drawing. Okay, and I did that by hitting 6, and now I'm going to hit 1 to draw the field. And so what this is doing is it's taking my area under the curve, all that fancy formal stuff we did in examples 1, 2, and 3, and it's calculating the slope of the tangent line when x equals 1, when x equals 2, and so on and so forth. Okay, now what you'll see here is the behavior of the graph based on where you're coming through at. So now this says this goes through the point 2 comma 0. Well, this slope, it looks like it changes, okay? Well, what does that mean it changes? Well, it looks like it kind of curves this way. It's steep, 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 and then it almost goes straight up, right? Just by looking at the slope field. Now, here, it looks like it's doing one of these deals, like it's going to come down and change its position. And there's a lot of changing there. Okay? And that's kind of what it looks like. That's almost exactly what it looks like if you look at it carefully. Okay? Now, I said that that's actually c times e to the x minus 1. Now I can plug in 2 and 0 and get the value for c and graph it. And so we'll do that real quick just to show you how to use the slope field. The textbook doesn't say to do this, but I'm going to do it. So if I say y is equal to c e to the x minus 1, and I plug in 2, then I get 0 is equal to c e to the 2 minus 2 minus 1. Or c is equal to e to the 2 minus 3. Okay? So now I'm going to say 3 over here, c to the e to the 2, or divide everything by e to the 2, and I get c is equal to 3 divided by e squared. So if I come out of this, oops. Oh, it's not wanting to cooperate today. Oh, I got to quit the program. So now I'm going to quit the program real quick by choosing option 7. And now I'm going to say 3 divided by e to the 2. And hit enter. And it's about 0.41, we'll say, if we round it up. So now if I graph that, I really should have left my red line up there, but I'm going to say 0.406 is what I think we had, times e to the x minus x minus 1. And I'm going to hit graph. See how that works? So now if you're doing approximations of something, and truthfully in the real world, if you're doing engineering and stuff, like, it's very complicated to find these equations. We're really watering these equations down so that you can understand the process of solving it. But we are interested in the behavior. In other words, there's lots of stuff I could approximate where the min or max is, so this would be like a minimum. And I could, like here the function is decreasing after the minimum, the function is increasing. And we could do all that without necessarily having the equations, just by knowing what the slope field looks like. Are there any questions on that?